Hello everyone, and thank you for joining me today for this installment of our Alteryx Weekly Challenge walkthrough. My name is Luke Bennett. I'm a data analytics consultant at the Information Lab, where I work primarily in Alteryx as well as Tableau. And today we're going to be taking a look at Weekly Challenge number 463, Let Designer Calculate the Pell Number Sequence. If you're thinking along the same lines as I was, you might be wondering, what are these Pell numbers and what are some applications for them? So as you see by my several Wikipedia tabs, I did some introductory research onto these Pell numbers, which are named after English mathematician John Pell, who was alive in the 17th century, and you'll also see here that he was apparently involved in some pretty elite philosophy circles as well. However, these Pell numbers, though they're named after John Pell, he actually wasn't the one who initially created the Pell equation that we use to generate these Pell numbers, and it's misattributed to him as some variants of the equation were found in ancient times, actually, in India and Greece. So, for some brief context as well, these Pell numbers are an infinite sequence of integers that reference the previous values in the sequence to generate subsequent values. And we'll look a little bit more closely at how we generate them when we start on this problem. But to tell you a little bit about what they're used for, they have a lot of applications in mathematics and geometry. The main one being that they're used to approximate the square root of 2. So for example, if we take a look at these fractions here, these denominators are actually some of the first few numbers in the Pell number sequence. And then these numerators are the current Pell number and the previous one added together. And as we keep generating these fractions, they get closer and closer to the best rational approximation of the square root of 2. These also have a lot of implications in geometry, so we can use them to generate some octagons. They're also used occasionally to generate the lengths of sides of different right triangles. And the Pell numbers are also related to something called the silver ratio, which is based on 1 plus the square root of 2. So as an example, we can see in this octagon here, the ratio of the sides is related to this silver ratio. To make this a little bit more relatable, you might have heard of the golden ratio and the Fibonacci sequence, which are very related concepts to the Pell number sequence. So if we take a look at this Fibonacci sequence, you'll see it's very similar to the Pell number sequence, where we have an infinite sequence of integers, and to generate new ones, we reference previous values in the sequence. In this case, we just add up the previous two values in the Fibonacci sequence. So we start with 0 and 1, and then if we add those two together, we get 1. If we add 1 and 1, we get 2, and so on. And this Fibonacci sequence is heavily related to the golden ratio, which you can use to make spirals like this. And this golden ratio is also found a lot in nature, such as with shells, with certain leaves, and is also observed in some classical architecture as well. But to go back to this week's Alteryx challenge, first of all, thank you to Kapil for submitting it. And we're given some context on what these Pell numbers are, a little bit of what I've just talked about, and it tells us the rule of how we generate these Pell numbers, which is we take the previous Pell number in the sequence and multiply it by 2, and then we add that with the Pell number before that one. So the formula that we're given to represent this is that for any number n, to generate the Pell number, we take 2 times the previous Pell number, which is written as n minus 1, plus the Pell number before that, written as n minus 2. So if we apply this formula as an example, for instance, let's say we're trying to find p of 3, which we're given here is equal to 5. What we would do is say p of 3 equals 2 times p of 3 minus 1, which is 2, plus p of n minus 2, which in this case 3 minus 2 is 1, which in other words is 2 times the Pell number for 2, which is 2, plus the Pell number for 1, which is 1. So that's 2 times 2, which is 4, plus 1 is 5. So that's an example of how we would use this formula to get another Pell number. The one thing that's really important to mention that we do get in the description of this challenge is that this sequence starts with 0 and 1. So we have to take it as a given that p of 0 equals 0 and p of 1 equals 1, even though if you plug those numbers into this equation, that wouldn't work. And that's because the equation references the previous value in the sequence and the value before that. So we need two values to start with in order for this equation to work. So we'll have to bake that in when we calculate this in Alteryx. And we'll also see that the specific task that we need to complete is to find the first 30 numbers in this sequence, starting with 0. So you can download the start file. I already have it ready to go here in Alteryx. And you'll see we get the same description as we had in the post, and our instruction to gather the first 30 numbers in this sequence. As always, we have our input, where in this case we just have 0 and 1 as our first two numbers in the Pell number sequence. And what we're trying to get is the first 30 numbers in the Pell sequence, all the way up to these pretty large numbers here for the 30th. So in this particular case, I'm actually not even going to reference this text input that we start out with. And I'm just going to start us off right away with a generate rows tool, which can be found in the preparation palette. And the reason I'm using this particular tool is because I want to have those 30 rows built out for me to generate the Pell numbers for. So what I'm going to do is I'm going to create a new field. We actually don't have any existing fields in this case because I'm not connecting any data in here. And we can call it something. I'm going to call it n because these numbers we're generating here are similar to these n values in the equation. So we're going from 0, 1, 2, and keep going up by one number until we hit 29, because that would represent 30 rows if we're starting at 0. So I'm going to call this field just n. Our initialization expression, which is just the value that we start with, I'm going to put as 0. The loop expression, I'm going to put as n plus 1. So that's just our field and then add 1 each time we go to a new row. And then our condition expression is when we stop generating rows. So I'm going to say n is less than or equal to 29 so that it will keep generating rows starting with 0 and then stopping at 29 to give us those 30 rows built out. So if I hit run here, you'll see in the results pane that I've generated this n column with my numbers that go until 29. So we get our 30 rows. And now I have to plug in the formula to generate the actual Pell numbers. So I've written out the formula here that we saw in the description of the post, where we multiply the previous Pell number by 2 and then add the Pell number before that, making sure that the first two numbers, which would be p of 0 and p of 1, have to equal 0 and 1 as our starting conditions. So because the nature of this equation is referencing previous values, what's going to be really useful is the multi-row formula, because we need to be able to make calculations that reference values that exist in different rows of our data. So in order to configure this tool, I'm also going to be creating a new field once again. I'm going to call this one Pell number. And I'm going to set the data type to an int64. We're going to take a look at this in a moment, but we want to make sure we're using an integer because that's the data type of these Pell numbers. But I want to make sure it's a bigger data type size because these numbers are going to get quite large and I don't want them to get cut off. Additionally, I want to make sure that I change the number of rows setting from 1, which is what it's set at by default, to 2. And the reason for that is that when I have it on 1, and I go on this X symbol here to my variables, you'll see that I just have access to the active row and then the row after it or the row before it. But in our equation, we need to reference 2 rows previously, which would be row minus 2. So I need to change this num rows to 2. So we get that row minus 2 option. And in order to recreate this Pell number expression, I can do that here. And what we want to say is 2 multiplied by row minus 1 of Pell number. So we're saying 2 times the previous Pell number plus row minus 2 of Pell number, the Pell number before that. And that's how we create that formula there. I'm also going to put some parentheses here. Our PEMDAS order of operations, if you remember that, will take care of us, but just makes me feel a bit better to have those parentheses on there. So that is the main element of our formula, but you'll also remember that we need to make sure that p of 0 equals 0 and p of 1 equals 1, and those don't work with just this formula on its own. So I'm going to need to create an if statement that makes sure that that's how we're setting it up. So what I'm going to say here is if I'm going to reference our n column, which is sort of like our row number or the n value. And I'm going to say if that n column is 0, then it needs to be 0. So we're sort of saying p of 0 has to be 0. I'm going to put an else if and do the same thing for when we're at the n value of 1. It needs to equal 1. And then once we make sure that that condition is satisfied, I can put an else to say for everything else after that, then we can use this formula we created here. And I'll put an end if to end this if statement. Once I hit run, we can take a look at the results here. And you'll see that we have successfully generated these Pell numbers, starting with 0 and 1, and then we have 2, 5, 12, 29, etc., which if we take a look back at the challenge, are these first few numbers that we got here. And they go all the way up to some pretty large numbers when we get to the 30th Pell number, or p of 29. Additionally, I mentioned before that we want to be cautious to change the data type to an int64, because if I change this to what we had by default of int32 and run this again, you'll see that I get an error of some of our data is not fitting the type int32, as we're going to have some nulls here at the bottom where our data is getting cut off. So that's why I want to make sure we have an int64. And that's all we have to do to generate those first 30 Pell numbers. So we have successfully satisfied our goal here. You will notice that in our output example, we do have just a regular row number that starts at 1 instead of 0. So if you wanted to add that, we could just add a record ID here. But for our purposes, we're satisfied with generating those 30 Pell numbers. And I do also want to note that, as always with these Alteryx challenges, there's many different ways that you can do them, which is a good part of the fun as well. So I did want to show off the way that I initially solved this Alteryx challenge before I found what I believe to be the most efficient solution with just these 2 tools here. And what I had initially done was once again use the generate rows, but in this case I started with 1 through 30. I created a formula to subtract that by 1 to get those n values, and then I actually joined in the text input that just had 0 and 1, and then united it, so we get a left join to preserve this whole list from 1 to 30. That messes up the sorting a little bit, so I fixed that here. And then we get this row number, these n values, and an area where we can add on the other Pell numbers here, which I use the same formula in the multi-row formula tool here as well. So that's all I have for you today for our walkthrough of weekly challenge number 463. I hope you guys enjoyed, and we always would love to see any of your thoughts or your own ways of solving this if you want to post that in the comments. And be sure to like and subscribe if you've enjoyed this walkthrough, and stay up to date on our future walkthroughs and all of our educational Alteryx and Tableau content. So that's all for me. Thank you very much, and thanks for watching.